Hi, welcome to this second lecture in CSE114, which is Introduction to Object-Oriented Programming. And in this chapter, which is titled Introduction to Computers, Programs and Java, let's see what do we have. So, since we need to discuss about programming, the best is to start, understanding the device on which we will be programming. So, I'm referring to your computer. Now let's see how much do we know about computer and what's the basic knowledge that we must have before we start learning programming. So what is a computer? You might find a number of definitions for computer. So the definition that I like about computer is I'll call computer as an electronic device which we can program. And in our textbook, I believe the definition of the computer is given as an electronic device which we can use to store and process data. So that's fine, right? I'm happy with both the definitions. But we should understand like what we should be calling as a computer and what not. So in that definition, I will probably not consider your calculator as a computer, although it does some computation, but we cannot program, right? So when we're defining computer, then I'll consider that as a device which we can program. So in that definition, I'll include our laptops, right? So if you have a laptop in which you can do Java programming, then I'll consider that as a computer. And this definition has to do with our course CSE114. All right, your desktop I'll consider as a computer. All right, so now let's not get into the details of what to consider as a computer and what not, and let's try to understand that if we have a computer like our laptop and the desktop in our lab, so what is in there, right? So what are the different components that make a computer? So computer has a number of important components. These are listed right here. So the most important component I'll consider as CPU, stands for Central Processing Unit. We will have memory, and there's a hard disk. We have monitor, printer. Well, printer may or may not be considered as a part of the computer. So printer you would need just in case you want to print something out. But anyway, that's fine. We can consider that as a part of computer. Okay, it's an output device. If it is connected to your computer, then you can print your program or any document using your computer. And communication devices you'll be needing if you have to hook on your computer to the internet. Okay, so let's see like what these things will do. What are the role of these components in a computer? Okay, so probably I have these definitions in the next few slides. Let's look at this picture that we have here. So these are the different components of computer: your CPU, memory, storage devices, communication devices, input devices and output devices. And all these devices, they need to be connected to each other, and then only we will be able to get the computer to work. All these components, they need to connect with each other, and that's how the whole computer is formed. Now these connection channels which connect all these components together are called bus or buses. Alright, so bus is the communication channel or the set of wires, you can say, which are usually printed on the motherboard. They connect different computer components. Okay, so the memory, the CPU, input and output devices, they're all connected with each other with the help of the bus. And the bus is used to transfer the data and the control between the different components, or the power, you can say. Some buses are also used to transmit the power. Alright, so let's look at the CPU and try to gain some fundamental information about CPU, which stands for Central Processing Unit. Now you might have bought a machine, or you might be thinking of buying a machine in future. So whenever you discuss about the computer, like maybe a laptop. Say you want to buy a laptop, then you'll have some configuration in mind. So configuration means that when you are in the market and you are purchasing a computer, or laptop, or a desktop, then you'll have something in your mind, like how fast my computer should be, right? How much RAM should I have? What should be my disk size? Right? And should I have CD drive or not? How many USB ports I should have? So all these terms and things you have in your mind when you go out to purchase a computer. So in terms of the speed, let's look at the factor which determines the processing speed of your computer. So the processing speed of the CPU, right? Let's stick to CPU for the time being. CPU is the main processing unit which executes the instructions for uh, in the software or a program, or whatever you can call it. So the central processing unit, its speed is measured in a unit which is called hertz. Okay, so these hertz, like so, your processor speed, if you ask, then somebody will say that your processor speed is some number in gigahertz, say 16 gigahertz. I'm not sure about any specific value, so I'm not citing that. But the fact is that the speed of the CPU would be measured in the unit of gigahertz, right? So why gigahertz? What is a hertz thing right here? So hertz, which is also written at HZ as an abbreviation, stands for is a unit of frequency. So that means the number of cycles per second. All right. So why do we measure the processing speed of a CPU in hertz? For that thing, you need to understand this fact that in a computer there is an internal clock, and this internal clock emits the electronic um, pulses, and these electronic pulses are used to synchronize the operation of the different components of the computer. So if your processor is capable of generating um, a large number of electronic pulses per second, then that means you can perform multiple operations, more operations per second, right? So that's the intuition you should try to have in your mind. So why do we measure the speed in the hertz? The reason being that it is to be synchronized by the internal clock that we have in our computer, and higher the clock speed, then that means that the faster the processor is, which means uh, if your processor or the clock speed is megahertz, then it means that in 1 second you are able to generate 1 million pulses, and these pulses are correlated with the operations that the processor performs. Okay, so that kind of understanding you should have, like process speed in terms of hertz, for the reason that there is a clock, and that clock emits electronic pulses, and these electronic pulses are used to synchronize the operation of different components in the computer. So if you have higher number of pulses per second, that means the higher frequency, that implies the higher speed or the performance of your CPU. So this much you need to understand about CPU for our CSE114. More details you will find in the textbook, which says that the CPU has two components, the arithmetic logic unit and the control unit, right? So all those details I'm not discussing in this lecture, because those I'll leave as an exercise for you. Okay, now let's go to the second component. We have already seen CPU here. Let's try to understand what is the role of memory unit in our computer. So this memory that we have is also called random access memory or RAM. Alright, so what is the role of the memory? So the instructions or the data on which the CPU works or operates, it resides in the main memory, right? So we have different words for memory. So what I should be doing, let me use a pen to make some notes right here. So this memory that we have here, it is also called as RAM. RAM stands for random access memory. Okay, and this is also called the primary memory. Primary memory. And in the memory or the main memory or the RAM, data and the instructions or the program instructions are stored, and CPU accesses the memory to retrieve the instructions and the data and do operations on the data using the instructions. So these instructions need to be present in memory, otherwise CPU can't work on that. So the purpose of the memory is to store the data as well as the instructions of the program. And there are, this memory is also called volatile for the reason that when the power is switched off, then whatever you had in the main memory is lost. Okay, so whatever you have stored in your main memory, which is RAM, is volatile, which means that when you reboot your system or when you switch off your system or your machine, which could be a laptop or the desktop, whatever information you had in the memory would be deleted or would be removed. Whereas we have another kind of memory which we call as storage device, or the secondary memory. So you had primary, this is called secondary memory. Storage devices, here these are non-volatile, right? So the storage devices, they also provide some memory means a device on which you can store data or instructions. All right, so you can store data or the instructions in main memory and also in this storage devices. But storage devices are permanent, they are non-volatile. That means whatever you have stored in your storage device, which means your hard disk or CD or the tapes or the USB drive that you have, these are permanent. Means that information which you have stored there, it will be there even if your system is turned off. Okay, so that's the difference you should understand. Okay, now this thing is important here. So 8 bits, right? We need to understand what is a bit here. So all right, now when we are storing the information in the memory, so memory would look like this. So let me make a very simple diagram for you just to explain how does a memory look like. So assume that this is conceptually, right, and conceptually assume that this is your memory, right, and here you are keeping the information, you're storing some information. Now the unit of the storage in memory is a byte. All right, so uh, unit of storage in memory. So when I'm saying memory, then that means your primary memory as well as the storage memory is a byte, right? We'll understand what is a byte. Now the question is, what is a byte? You are saying that the data that you'll be storing in the memory will have the basic unit as byte. Now you will ask me, what is a byte? So I should say that byte refers to 8 bits, right? 8 bits means a byte. Now you should say, okay, fine, you're defining byte in terms of bits, but what is a bit? So this bit, right, bits stands for binary digits. uh, Sorry about that, I should have digit. Binary digit is called bit. I'll be giving a lecture on number system, and that's where you will learn in detail about bits, right? So binary digit is called a bit. And you know let's spend some time on digits, right? It's worth discussing that right now. Let's look at digits. Decimal. All right. So the number system that we use, I mean the human being in our day-to-day life, we use decimal digits, and these digits are 0, 1, 2. It goes all the way till 9. So we have in total these 10 digits. Alright, so we have 10 digits in our decimal number system, and these digits starts from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. These are the 10 digits in decimal system. In binary digits, right, which is also called bit, we have just two digits that are 0 and 1. In binary, we have only two digits, 0 and 1. Now, the interesting thing about computer is that the computer is composed of circuits, right? So there are a lot of uh, you know if you go to the detail, I mean, if you go to the depth of mm, the hardware, like if you try to understand what is there in the computer, what makes a computer, then you will find that there are a lot of integrated circuits inside. And then basically, if you go and try to find out what is there in these ICs or integrated circuits, which make your different components and hence the whole computer, these are bunches of these are a bunch of switches, right? And these switches that you have, switches, all right. So computer um, is basically made of switches, and these switches can remain in two stages: on or off. All right, so this on and off is represented with these digits. 1 means on and 0 means off, right? So ultimately, how is the data represented? It is represented in the sequence of zeros and ones. So whatever number or the data you can think of, as an example, number 3, right? So this number 3 that you have, which we as human being will say that this is number 3, but for computer it will be converted into binary, and it will be represented as 1 1, 0 0 0 0 0 0 1 2 3 4 5 6 7 8. All right, so the point is that everything that computer deals with would be in binary, in bits. All right, so it might be I'm not sure how much you are following, but don't hesitate. If you have any questions, please reach out to me and my TAs. Okay, so it might be too much of detail right now, but let's try to get some intuition behind it. So if I have to represent 3 or store 3 in my memory, then I will store that right here as 1 and 1, and then 1 2 3 4 5 6 7 8. Why 8? Because that's the basic unit. Every number or whatever you have should be stored in a byte. Why should I call it a byte? Because I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 bits, right? So this number 3 that I have, I represented that in 8 bits, and since it is an 8 bit, so I can call that a byte. Alright, so everything that you have in the memory would be stored in binary. And what we have, I'm showing you a segment of your memory, which is our RAM. Right now, each byte that you have, it will have some address. So let me put some address with the help of some numbers. So assume that it is starting with 200. So number 3 that you have, you stored at the memory address of 200. The next thing you can store at 201, 202, 203, 204, and so on. Okay, so every memory, every byte in our memory will have an address, and that's how we will access the information. So if the CPU wants to get this value 3, right, then it will have to reach out to this memory location, and from that memory location it will retrieve the information. All right, so that's about you know uh, the memory. Okay, I think this much is sufficient. You don't need to know more than that in this lecture about memory. Now, let's get to the programming thing now. Okay, rest of the details are not so important. Well, maybe about these things you might be knowing. The input devices are important. So when you are doing programming, you will be mostly using keyboard or the mouse. Initially we'll be using just the keyboard. We will use keyboard to type the program uh, in on an IDE, or maybe on an editor, and then you will save that. And when you have to run the program, you might be asking for some input from the user. The input you will be providing by through the keyboard. So keyboard and the mouse are the example of input device in our computer. And how about the output devices? The output is something that you see on your monitor, and this monitor might be an external monitor if you have a desktop, or if you have a laptop, then the screen that you have, which is connected with your laptop, is your monitor. Okay, so the screen becomes your monitor there. And do we have another output device? Yes, we have a printer, right? So whatever, in most of the cases, if you want to print some document which you have on your machine, then what you do, you issue a print command, and that document is sent to the printer and it is printed out. Alright, so printer and monitor are the output devices. Keyboard and mouse are the input devices. Okay, so now let's get into the programming thing, right? Because we have to learn about programming. So let's see, like, why do we need to have a programming language, and what is a program? Okay, so if you ask me, like, what is a program, then I'll say the program is the set of instructions. Alright, so I'm looking for my slides. Probably I don't have the definition of a program, but that is simple enough. So program means the set of instructions which we want our machine to follow and do some task for us. Okay, that's the program. Now the point is, fine, program means the set of instructions which you have written for your computer to execute. And now the second question that arises is that how should you write those instructions, right? So these instructions that we are writing should be understandable to computer. And that's the purpose of the programming language that we are learning. These languages should make some sense to our hardware, which is our computer. Alright, that's the whole purpose. Now, in these programming languages that we talk about, we have different categories. right? So these slides that I have will give you some idea about these programming languages, right? So we have something called as machine language, then we have something called as assembly language, and then we have high level languages. So let's try to understand, like, why do we call a language as machine language, then another set of languages called assembly language, and then we have the high level languages. So the first thing that you should think about is that why do we have these three different categories? Alright, so let's try to understand each of these categories one by one. Now, as I told you that the computer kind of works in binary, right? I have given you that concept already. So the hardware only understands the instruction in ones and zeros, right? Because it is basically composed of switches, and these switches can be on or off. All right, so they can remain in one of those stages, or status you can say, or state you can say, on or off state. So the language that our hardware understands is the machine language. Alright, so and machine language would be something like this, so you're looking at your machine language is right here. This is the machine language. Alright, so the instructions that our hardware understands is the bunch of zeros and ones, right? And any instruction, I mean, if you've written a program, let me make an example program which may not make any sense, but let's think of some program that has four instructions. So I can come up with some arbitrary instructions: 0 1 0 0 1 1 1 2 3 4 5 6 7 8. That's my first instruction. Second instruction could be 1 0 1 1 1 2 3 4 5 6 7 3 4 5 6 7. Oh, sorry. 1 2 3 4 5 6 7 8 and 9. So I added one more bit, 8 bits, right? 1 byte. So I'm just creating an example, okay? So don't take it seriously. 1 1 0 0 1 0 1 0. Some arbitrary instructions: 1 1 0 0 0 0 1 1. Alright, so this is my program. It is in my machine language. Why is this thing in machine language? Because if you look at it, then it's the sequence of zeros and ones, which is in bits. And this is something that my computer hardware will understand. Hardware only understands machine language instructions, right? Now if this is something I tell you, right, then and then I ask and I tell you, then this is the machine language, and let's try to learn some machine language. So for machine, this is very fine because it's the mother tongue of the machine, follow zeros and ones. But for a human being, it is very difficult to think at that level. You'll have to do probably you'll have to memorize a lot of sequences like this, and this is not convenient for a human being to remember. All right, it won't make sense to us, right? It won't make much sense because uh, human being, we work at a very abstract level, not at this level, right? So that is a problem. That was a problem initially when the computer was new. We were just learning to program long time back, right? When the concept of the computer came into existence, that time it was fine. There were some smart people who came up with the concept of the computer. They designed it. They started programming, and they knew what were the instructions, and they probably started programming in machine language. That was fine. But later on, as these things evolved, as the computer design got evolved, and more people they showed the interest in programming, then the need was felt to make it more human friendly, right? So machine language was not the solution then. What was felt a need was felt to kind of generalize it, right? So this machine language should be made human friendly. That was the need, human friendly. And how will you make it human friendly? That means let's have some uh, you know instructions which make sense to the human being. All right, so what was done after that, the machine language, another language on top of the machine language was thought about, and that other language was called assembly language. All right, so assembly language was proposed on top of the machine language. And assembly language was more meaningful, right, more understandable to human being, because in place of these sequence of zeros and ones, people came up with these symbols, right? Add, subtract. So for addition operation, if you have to do, there were these symbols like add for add, for subtraction sub, and similarly you can think of division and multiplication as well. And these symbols that you have were called mnemonics, right? Probably I don't have that term here. Mnemonics. All right, mnemonics means these symbols, like add means you have to perform the addition of two values. Sub means you have to do the subtraction of two values which are provided to you. So how will an instruction look like in assembly language? You'll have something like this: add F3, R1, R2, R3. So this is little detailed. So let me give you some intuition about it. What we are doing here, we want to add the numbers which are stored in register R1 and R2, and we want to store the result in R3. So R1 and R2 and R3, these are some registers. Alright, registers are again some memory unit kind of a thing where you store the value. Now again, you don't need to get into the details of all these things. I'm just giving you some idea behind it, like how an instruction would look like in an assembly language. So assume that I have the value 2 in R1 and the value 3 in R2, then this add F3 R1 R2 R3 would result in addition of 2 and 3 and assigning the value of 5 into R3, right? So I believe that with this much of information you should get this intuition that this kind of instruction is more human friendly compared to the sequence of machine instructions which are written in zeros and ones. Okay, so that was the difference between machine language and assembly language. Let me see what do I have in my slide. Machine language is a set of instruction executed directly by a computer's central processing unit. So these things CPU will directly work on and will execute, no problem for CPU at all. A program called assembler is used to convert the assembly language programs into machine code. Now this is interesting. Oh well, back to this history that I was explaining to you. Uh, because of the fact that this machine language was not very user friendly, very human friendly, so the concept of assembly language came into existence. Now these instructions which you have written in assembly language are more interpretable or more understandable to human being, but these will not work directly on the machine or the computer. Why? Because computer understands zeros and ones. What you have written is not in zeros and ones. This is an instruction which will make sense to the human being but won't make sense to the computer. So what we needed was another program which will read the instructions that you have written in assembly language and will convert that to the machine language. Why do we need this conversion? We need this conversion so that ultimately these instructions which are in assembly are to be executed, and they won't run, they won't be executed unless these are translated into machine code. Alright, so for that we needed a program called assembler. What assembler does? Assembler takes the instructions written in assembly language, like the same instruction, and converts that to the corresponding binary code instructions. So that binary, or you can call that machine code instructions, so that the computer can run that, so that the machine can understand and run that. All right. Okay, good. So yeah, what was the benefit that we achieved by having an assembly language? It was far easier to use than binary. But again, if you are programming today, then you will say that assembly language is not that much fun. If you have already used some programming languages like Python or even Java, and after that, if I say that let's do programming in assembly language, you will say probably it's not fun. It's still very low level. Those operations that you're doing here, you should know that R1 and R2 are registers. You will have to probably work at the level of the registers, which is registers are some very fast memory units. It's very hard, too much of hardware depth that you need to have to understand what registers are. But the message is that for assembly language also you should know a lot about the hardware of the machine. Okay, so you should be well familiar with the architecture of the machine or the computer on which you are doing assembly programming. Okay, so it is still not very user friendly. It's better than the machine language, but it is still low level. All right, so what was needed? We need a language which is very close to human being, right? And and the languages which are very close to the human being means those languages which are similar to English language, right? We cannot write program in English language and make the computer run that, but whatever language that we use, it should be very close to the human language like English. So further advance, further research were done and more languages were proposed, and these languages which are kind of considered very friendly to human being, they are classified in this category of high level programming languages, HLL, high level programming language. These are more user friendly, easy to use, are more flexible, and these are platform independent. So platform independent is something I will discuss in detail in this lecture, more so for the reason that the Java language which we have to use in CSE114 is famous for its feature of being platform independent. Now here let me draw one diagram for you which will give you this idea about you know the the level of programming language. So you have this hardware, right? Hardware means your computer hardware that comprises of your CPU, your memory, your input devices, output devices, buses, and memory, storage device. Okay, so hardware understands the machine language. Alright, so machine language is something which is closest to the hardware. This is the language that hardware understands. On top of machine language, we have assembly language. Right, so assembly language is again not that close to the hardware as is your machine language, but is still close to the hardware. So assembly language is also considered as low level programming language. Alright, do I have that term here? Alright, that's fine. You can call it low level programming language. On top of assembly language, then we have some languages like C, C++, and you have language like Java, Python, So all these languages which are kind of away from the hardware, right? So there are one, two, three. So at this level, these languages like C, C++, Java, and Python, they are called high level languages, HLL, high level programming languages. And here is the user or the programmer, right? Or the programmer that is programming, right? That's the reason we call these languages like C, C++, Java, and Python as high level programming language, because these are close to the human being, high level from the hardware. Whereas the languages like machine language and assembly language, these are called low level, because these are close to hardware and these are more specific to the hardware. In order to use this low level programming language, you should have a pretty decent understanding of the hardware architecture or your computer architecture. You should know how many registers you have. You should know, how to, deal with those things. Alright, so this much I believe is sufficient for our understanding of different level of programming languages: machine language, assembly language, and high level languages. Okay, so now let's have a look at the popular high level languages. So COBOL was very popular, I'll say maybe some 20 years back. Similarly, the Fortran was very popular that time around, maybe in 80s or late 70s. After that, we this basic came, then Pascal, then Ada, then came C. C was a very popular programming language. It is still very popular, but again, it is now considered as very close to, um, it's not a low level programming language, but we call that as a system level programming language. System level, that means if you are writing an operating system, then yeah, you might go with C because it is very efficient. And programming in C is very challenging, but it is very, very efficient. These codes that you write in C are very, very fast. But C is a high level programming language. Then came Visual Basic, Delphi, then C++, C Sharp, and Java is right here. Okay, and we will be studying Java. So you can add more. There are a lot of languages which are missing in my list because there are so many. And I will always encourage you to read the textbook because there is a lot in the textbook, and I won't be able to cover every detail in my lectures. So, one interesting thing that you will have in your textbook is about the fact that the question is which high level language is the best, right? So unfortunately we cannot say that C is the best language, or Java is the best language, or Python is the best language. So we need to pick a language specific to the job that we are doing. If I have to write a system level program, if I'm writing an operating system, then I will prefer C over Python or Java. And if I have to design some software which should be platform independent, that is which is supposed to work on multiple platforms, I'll go with Java. And if I'm prototyping, that means I'm working on something that I need to finish really quickly, and it's some data analysis kind of a job, then I might prefer Python, right? So the message is that we don't have one absolute winner in terms of the programming language. um, it depends on the application that we are working on. Depends on the software that you're designing, right? So on the basis of the program that you're writing or the problem you are solving, you might prefer one language over the other. But if you have to, if you're thinking of making a career in softwares, right? You want to be a software engineer or you love writing programs, then the message for you is to be ready to learn more than one programming language. And the good thing about programming language is that if you learn how to program irrespective of a language, right, then the transitioning from one language to the other language is very smooth. Okay, so as an example, if you learn to program in Java in CSE114, then from that the transitioning to other programming languages like C++ or Python would be very very easy. And if you already know a programming language like C or Python, then you know how to program. From that understanding of programming, transitioning into Java would be very smooth because you know how to program. The only thing that will change would be the syntax. Okay? Yeah. Alright. So now let's try to understand about another software which is a compiler, right? What is a compiler? Alright, so do we know what is assembler? Alright, what is an assembler? I just explained, right? In the previous few slides I explained. So assembler is a program. Let me take you back to the what does assembler do? Assembler takes a program which is written in assembly language and translates that to a machine language so that the computer can run that. So the same role we have for compiler also. So what will a compiler do? Let's try to understand. It's a software program again. What it does is it takes the input as the instructions of the program which is written in high level language. What is a source code? I will explain that to you. We will write a source code, right? So source code means your program. Source code means your program written in high level language. Let's discuss in terms of Java. Okay, so Java, so it could be Java or C or C++ or any programming language. So the program that you have written in a specific programming language would be called a source code. So what compiler does? Compiler is a software program that will take the input as a program which is written in a high level programming language and it will output an assembly code. Alright, and that assembly code would be finally converted to the executable, and then the executable would be run by the hardware. So the message is that the program that you've written in Java or C or C++ is something which is convenient for human being to use and understand and write program in. But that program which you have written in Java or C and C++ cannot directly run on your computer. We need another software called as compiler so that the compiler can convert the program or the instructions that you have written in high level language to ultimately the form which hardware can run. Alright, okay. So what is usually done is, let's have a look at this picture because this will explain better. You have a source file here, which means a program written in Java. You will use a compiler. The compiler will convert the source code into a machine language code. And what might happen is that the program that you have written may not be sufficient to run. So I will write a demo program today, and I'll tell you that I cannot write everything for my program. I might need some help from the programs which are already written in Java. So I'll make use of some existing programs also for my program that I have written. Okay, so often what is done is that our program which was written in source file got compiled, we got an output, right, which is machine language file, or it could be assembly language, right. Let's not distinguish much when we are dealing with the compiler. Now this is the output that you got after compiling your own source code. Now if in your source code you were referring to some code which is already written by Java, then there's this module linker. What linker will do? Linker will take the output of the output of the compilation stage, and it will also use the library code which you are referring in your source file, right? So you'll say that, I have done a part of my problem or the program, and the remaining I will use from the library, right? So this code is already written in the library, I want to use that. So what linker will do, linker will take your part that you wrote and the part of the library code that you're referring in your program, will combine that and will finally create an executable file which will run. Okay, so all these things, these stages are involved in running your program. Okay, so these things are fairly simple. If you are new to programming, it may take a little bit for you to understand, but uh, the first thing that I should communicate to you in this course is that programming is very, very conceptual, right? If you are trying to memorize the things that I'm teaching, then probably you're not getting it, right? You need to get the concept behind programming. Memorizing it is not the way, right? So go through these things, right? Go through my lectures, read the textbook, and it will make a lot of sense, right? This is the sequence that we have in programming or in the compilation process. Okay, good. So fine, we did understand about assembler, we got some understanding of compiler. Let's look at another very important system software, which is called operating system, right? Operating system is the most important software that you should have on your machine, right? Because what we have is a hardware, right? So now the things have changed a lot. Long time back when I was a student, we used to purchase the raw hardware. We used to assemble different components, like we would take the motherboard and we'll put the CPU there, the RAM there, we'll connect different components, and then we used to when the system was ready, when the hardware was ready, all the components were connected, then we used to install the operating system ourselves, right? But now things have changed a lot. The branded machines are a lot cheaper now. So what we do, we order the machines. Say I want to buy a Lenovo laptop. So I will order the Lenovo laptop online, and probably I will specify that it should come pre-installed with the Windows 10, right? Or Windows, whichever version you want. So now when the machine is shipped to us, then it comes pre-installed with the operating system. So we don't realize that it's such an important software to have. Without the operating system, your computer is just useless. It's just it's just a machine with no soul there, right? It's just a body without a soul. So operating system is a program that makes your hardware usable. So that's the definition I prefer for operating system. Is a software that makes the hardware usable, or that makes the computer usable. But this definition is also good. The operating system is a program that manages and controls the computer's activity. Okay, so there are a lot of things that goes behind an operating system, which you will learn about when you take the course operating system. Okay, good. So we have different examples of the operating systems. Windows had a number of um, Windows had Windows XP, then Vista, then Windows 7, Windows 8. Now we have Windows 10. So these are different versions of Windows operating system. You have Mac OS for Apple machines. Then you have Android, which is for our mobile devices. Then you have Linux operating system. We also had Unix system. So Unix. So these are all example of operating system. So here we have a picture that gives us an idea about what's the role of an operating system. So when you have a hardware, then the first software which we need to install on the hardware is our operating system. Then once you have the hardware, you install the operating system, and now your machine is responding. And then you should think of installing other softwares on top of operating system, which are called application programs. Excuse me. So the example of the application programs could be your web browser, your word processor, spreadsheet, so on and so forth, right? So word processor means MS Office or MS Word, right? Spreadsheet could be MS Excel. Web browser could be your favorite web browser like Chrome, Mozilla, Internet Explorer, right? So these are the example of application programs which are installed after the installation of the operating system. Then you have a user sitting right here, okay, and the user will make use of these different application programs. But these application programs are using the operating system for interaction with the hardware. Okay, now let's get to this important thing, like what we have to learn. We will learn a lot of things, right? We will learn how to program, we'll learn about different programming structures, we'll learn about conditionals, iterative statements, loops, different switch statement, a lot of interesting stuff. We'll learn about classes, we'll learn about methods, we'll learn about inheritance, polymorphism, a lot of stuff. But the medium for this thing is Java, right? So that will be our programming language, right? So all of these concepts are generic, like inheritance is generic. So you can have inheritance in C++ also. We have the feature of inheritance in C++. We have methods or the functions in C++ as well. So we have for loop in most of the programming languages like C, C++, Java, and Python. So we'll learn a lot of stuff. We'll learn about the logic that goes behind writing a program. But the language that we'll be using would be Java. Okay, so that is fixed. So now in this lecture, let's establish this fact that Java is an important language to learn, is worth learning, right? So it will be fun, but you might find that challenging at times. So it's worthwhile. So all the hard work that you'll be putting in the CSE114 in learning Java is worthwhile. So let's try to understand, like, why is Java so important? Why is so much of demand of Java in different companies around us, right? So there are a lot of jobs that needs the candidate to know Java. Okay, and why do we teach CSE114 with Java? So Java has this principle which is called write once, run anywhere. We need to try and we need to understand what is this. Write once, run anywhere. You can abbreviate there. You can have the abbreviation like WORA, write once, run anywhere. So what does that mean? So all these things like write once, run anywhere, and platform independence, that means the same thing. Okay, so what are these things? Let's try to understand. So before that, right, before giving you this idea about platform independence, let me tell you about Java. Like, why was Java invented, right? When these people, James Gosling, who came with this language, who designed this language, they had this project. They wanted to come up with a programming language for embedded devices, right? So they wanted a language which can run on different kinds of devices, right? So their objective of designing Java was totally different from the objective of designing any other language, right? So people who designed C or C++, they had something different in their mind, and those people who worked on Java and who designed Java, they had a different goal in their mind, and their goal was to come up with a language which should be able to run on different kinds of machines, right? So they wanted to design a language which could run on different kinds of hardware. All right, so that's the reason that this language is, by by birth you can say, or by its nature, is platform independent. It can run on different kinds of hardware or the platform. Okay, so now, how was that possible to achieve, right? So platform independence that we talk about in Java is unique to itself. You cannot have that platform independence in C or C++. Why, right? So the question is, what makes Java platform independent? So Java has this feature called Java Virtual Machine, right? So in order to run the program which is written in Java, you should have this program called JVM running on that machine. Alright, so you'll be doing this installation with the help of the TAs and with the help of my instructions for your lab works and your homework, and that involves the installation of JDK, Java Development Kit, and an IDE, and you need to set up all those things so that you can ultimately write your program and run. And I'll give you a demo today as well. So when you install your JDK and when you install your IDE, then what will happen is you will run some um, important components for Java which are needed to compile your program and ultimately run your program. So the program which ultimately runs your program which is written in Java is called Java Virtual Machine. So this Java Virtual Machine is a program which is responsible for the platform independence of Java. Okay, that makes Java platform independent. Okay, so what is the role of JVM and where exactly JVM comes into picture? For that, let's try to understand how a Java program is executed, right? What are the different stages involved in running a Java program? So, as is the case with most of the high-level programming language, first the Java program is to be written uh, in a file. So you need to create, let me add some details here. You will create a Java source code. I'm going to do that today. Okay, so don't worry. You will create a Java source code which will be written in a file. In a file. And the file would be named .java. That's the extension for Java file. So you wrote a Java program in a file, and we will call that a Java source code. Now we'll use a compiler, and that compiler will convert this instruction which was written in Java into something which is called as Java bytecode. Alright, so compiler converts the instructions that you've written in Java into an intermediate program, right? Intermediate. This is the intermediate. It's the intermediate program. The intermediate program that you have is written in the bytecode. Now, bytecode is something which JVM understands. Alright, so these bytecodes that you have is something that the JVM will execute. Alright, so the compilation or the execution of the Java program is a two-stage process. In the first stage, you compile the source code which is written in Java into bytecodes. Now these bytecodes, once you have, you can run these bytecode on any machine that has a JVM running on that, and that's how we achieve the platform independence, right? So if I have three different kind of machines, one is running Windows operating system, the other one running you know Mac OS, and the third one running a Linux one. But in all these three different platforms, I have JVM running, which is Java Virtual Machine running, then the Java virtual machine that we have on these three different machines will take care of running my bytecode. All right, and bytecode I can generate anywhere. All right, so that's how we have the platform independence. So I found this these pictures very interesting on the web, and I put that in my lecture today. So let me show you the difference. Let me once more give you this explain this platform independence idea of Java. So we'll come to platform independence later. Let's look at some other languages and try to find out like how how are the things there with the languages like C and C++. So pay attention to the figure that I have in the left. You wrote the program in C or C++ programming language, and now we have these three different platforms. That means we have three machines. Let's make it very simple. Let's assume that we are working in a lab. In the lab, we have three computers. One is Windows based, the second one is Unix based or the Linux based, the third one is the Mac machine. Now, all these machines that you have, they'll have their own compiler, right? So you'll have a C compiler or C++ compiler which is made for Windows. You have a C or C++ compiler which is made specifically for Unix, and then you have one specifically for Mac. So these three compilers, although these are for the same programming language, which is C or C++, but these are specific to the operating system that we are using. So what you do, the program would be same, right? As goes the program, you can use the same source code, and the same source code will work on these three different machines. But the compilers that you have in these three machines are all different. So what happens, these compilers that you have on Windows will convert the executable into window executable, right? And similarly, the Unix operating system that you have has a Unix say compiler. It will compile the C source code and it will convert it to the Unix executable. Similarly, the Mac will convert into the Mac executable. And why do we need these specific executables? Because this window executable is to be done by window machine. Unix executable is to be done by Unix machine, and similarly Mac executable is to be done by Mac machine. So here you cannot swap, you cannot take Windows executable and it will not run on Unix or Mac machine. Similarly, Unix executable will only work on Unix, right? So here we do not have platform independence, right? So what we will have to do, if you want to take the same source code which is written in C and C++, C or C++, and you want to run that on different kinds of platform, then you'll have to use those specific compilers. So here you have write once and compile anywhere. So you will have to compile at different places to get that to run on different platforms. Alright, now let's see like how is the situation with Java. This is a program written in Java. Don't worry about the program structure because something like this I will create in my lecture today, and I'll explain to you like why did I write program this way. But if a program is written in Java, then what will happen? You have a compiler, right? So the compiler that you use in Java will convert the source code into a bytecode. Now the same bytecode that you have, you can take to any platform. So the result of the compilation right here, when you compile, you get right here. So the same stage that you have here, instead of generating the executable which are specific to the operating system, what Java compiler does is it generates the intermediate code which is in a bytecode, right? And this bytecode is not hardware specific. This bytecode is the language which Java virtual machine understands. right? So because of the fact that the result of the compilation process gives us a program in the bytecode which JVM understands. So if you have the JVMs running on different kind of operating systems, then we don't have a problem at all, because now it's the responsibility of the JVM to convert the bytecodes to the executables, execute um, compatible to the operating system. So the JVM which is running on Windows machine will take the bytecode and will convert it to the executable which are window compatible. Similarly, the JVM which is running on Unix will interpret, right? So after compilation, JVM does the interpretation, right? So interpreters are similar to compilers, but they work slightly differently. Let's not go into that detail. In the textbook, we do have that detail. So if you're interested, you can go over that. So JVM is an interpreter, and it will translate the bytecode instructions to the hardware specific executable. Similarly, the JVM that we have for Unix will convert the bytecodes to the Unix specific executable, and same would be the case with the Mac OS as well. Alright, so this is something you need to understand since you are doing Java programming. And if somebody is saying what is the strength of Java, well, Java has a lot of strong points, like it is object oriented, so it has all those features of an object oriented programming language. But one of the strongest point in favor of Java is its platform independence. So you need to understand this concept. Okay, so here also we have the same information that I have in the previous slide, but this picture is from your textbook, so you'll find this in your textbook also. So I will not read these things, I'll go over the picture right here. So you wrote a welcome.java program which I will write today, and it was compiled by the Java compiler that will generate a bytecode. Now this bytecode would be combined with the library code, so that if you need some support from the classes or the programs which are already supplied by Java to you, then all these things are combined and are finally run by JVM. Alright, so it is that was the bytecode with the library code combined, and it is finally being interpreted by Java and finally runs. Okay, so this thing and what you have in the figure B are kind of related. You have the hardware. The hardware could be any computer. It could be Mac machine, Windows machine, Linux machine, doesn't matter. What we need is that there should be a program running on those different machines, which is called JVM, and this JVM will finally interpret the bytecodes. Alright, so this understanding is important for you to understand the Java, the feature of platform independence in Java. Alright, so what we will do, I should write a program and should walk you through that program, like why I'm writing that program in that specific way, and then I will then show you like what is going on in this figure. So for that, let me come out of this lecture slide, and I have few things here, right? So I will instruct my TAs to help you out with some setups, and I will also share some documents with you which will help you in setting up the JDK and installing your IDE. But in this lecture I am not using any IDE. What I am using is an editor, which is Sublime editor. So you can have a number of editors. You can use Notepad, you can use Notepad++, you can use Sublime, or you can use any other editor of your choice. So why am I using an editor? I'm using an editor to write a Java program. right? So when you write a Java program, you write that in a file and then you compile it. So let me start writing the program. Okay, so I will start with these two, forward slash, I should say, and I'll say my first Java program. So the reason why I have these, forward slash is that I'm writing a comment. Comment means I'm asking the compiler to please ignore this line. Don't convert it. It's my own statement, right? It is whatever I have written here is intended for a human being to understand. It is not for the compiler. I'm just happy about the fact that I'm writing my first Java program. So this is a comment. Please don't compile. Right, so this is something I'm asking the compiler to please ignore this is just a comment. So in your program often you will be writing comments, and these comments are for the human being who is reading your program and is trying to understand what you have done in your program, right? So there are a number of ways in which you can comment. This is one way, it's called one line comment. Okay, all right, so let's start writing our first program. So how do we write the program? Let's say public class welcome. All right, so it may, I mean, if you are new to Java, don't expect that you'll understand everything about the first program that we are writing. It may take at least 1 week in order to understand, like, why did we write our first program in this way. Okay, but you will learn a lot, right? If this is the first time you're looking at Java, then you will learn a lot. You may not understand everything 100%, but yes, at least 60%. Everything is new for you. All right, so for every program that you're writing, you should have at least one class in Java. Java is truly object-oriented programming language. You cannot write a program without a class. So whatever you have to write, it should go in a class. Now this public is a keyword, class is a keyword. Keyword means, let me write these comments for you. These are the nodes, right? Because Java will ignore. Keywords are are um, keywords have specific meaning in Java and we can't use it otherwise. When you are saying something as public, then it means something for the compiler, right? Public is a keyword, class is a keyword, but welcome is not a keyword. What does it mean? If you want to call welcome something else, you can say, right? So I can change welcome to welcome CSE114. So this is something I can change, but I should not change class. I should not change public, because when you say public and class, then these are some instructions for Java which we should not change. Okay, so what we are doing here, what I have done till now, I just created one block. Alright, why is this a block? Because whenever you use the opening curly brace and the corresponding closing curly brace, then these two together will define one block. And what I have done, I define a class block, right? So what the whole program that I have to write should be written in the class block. Why is it a block? Because I'm using opening curly brace and the closing curly brace. All right, so in the class you can have the data as well as other methods, but we don't need any data for this program. It should be very simple. So I will write another block. Let me write that public static void main, and here I will say string blocks. All right, good. So let me stop right here and explain to you like what I did. So here again I created a block, right? Because I told you that whenever you have a starting curly brace and a corresponding closing curly brace, then whatever you write inside these two will make a block, right? But the outer block was a class block because I had a keyword like class. But this keyword, this block that I have inside is, um, let me write a comment again. The block below is a method block. So we are creating a method, right? So you will know about method. Don't worry, we will have lectures. I'll have one lecture at least on methods, and I'll explain to you in detail like how do we write a method. Now, as I said that every program that you're writing in Java should have at least one class. Let me add one more detail. In every program that you're writing in Java, it should have at least one main method. Alright, so this is a main method. Below is a main method block. So you can have a number of methods in your program. So if you already know about programming, then the methods are same as functions. So in C and C++, C, C++, and Python, we call methods as functions. So functions and methods are same. In Java, we call functions as methods. So right here, we are defining we are creating a block, method block, okay, and here let me tell you about this fact that, as I said, in the outer block, public is a keyword, you cannot change that. Static is again a keyword or a reserved word, right? So keyword or reserved words, okay, sorry about this, there is a typo. Keyword or a reserved words, they have specific meaning in Java, and we should not use it for our own purpose other than what they are meant for. When you say something as public and static, it means something for Java. What is this something? For that you need to have some patience, right? I cannot explain that in the very second class. Void is also a keyword, we cannot change that. Main is the name of the main method, so we should not change this also if you're writing your main method. Otherwise, for any other method, we'll have a different name, then you can change it. So this thing that you have in the parenthesis, just this is also, I'll say, you should not change. So the good news or the bad news is that, the bad news is that you will have to kind of practice or memorize this this much. All right, you for main method, you need to remember that main method is to be written this way. This will be same for most of the programs that you're writing where you're using a main method. This is what you have to write: public static void main, and then you will be writing parenthesis, and the parenthesis you will say string and square brackets, then args. All right. So I don't know, maybe you should ask me this question that in this lecture few minutes back, maybe some 15 minutes back or 20 minutes back, you said that programming is very logical, is highly conceptual, and we should not memorize, but now you're saying that we should memorize. Well, not exactly. You don't need to memorize, you need to practice. When you write programs like this hundreds of times, you will anyway remember. Okay, don't memorize, just practice. By practice, you will um, sorry about that, there's a copy here again and there's a typo here again. You will when you will practice, you will understand. And anyway, when the time arrive, at the right time, I will tell you why did we write the main method in this way. Very soon I will explain, maybe in a week or so I will explain to you like why did we write main method in this way, but not today. Okay, fine. So now when you have created this method block, then let's write something which will run. Alright, so what I will write, system dot out dot println, and I should write hello CSE114. Okay, so this is my program is complete now, right? That's the good news that my program is complete now. I won't be writing anything additional. I want to keep it very simple. So in this main program that you have, the main method that you have, I'm writing just one instruction, one statement only, just one statement. What is a statement here? In a program you'll have a number of statements, right? Number of instructions will finally make up your program. Now the first statement, I'll call it a statement because it is terminated by a semicolon. So every statement in your Java needs to be terminated, and we terminate that by using a semicolon. Alright, so that's the only statement I have in this program. If you want, you can write similar system.out.println, and the effect would be that whatever you have in the parenthesis and in between double quotation would be printed out when you run this program. Alright, so there are more details in here, like why are we using system, why are we using out, why are you using println. I will explain these things because I have that in my lecture slides. Alright, so what I should do right now, let me save this file. You have done all this hard work, you typed your program, you have written a source code here. What all I wrote in these 8 lines of Java program is my source code in Java. So I should save it. I will say save as, and I'm right here in the C drive, CSE114. So I'll go to C, CSE114, and pay attention now. This is important too. I should call this file as welcome.java. So why welcome.java? Because welcome is the name of my class. So the file name in which you are writing your program should have the same name as the name of the class that you have. So I should save this program in a file called welcome.java. Let's save that. Good. So you should see that after saving this file as .java, it has some syntax highlighting. Why? Because this editor that I'm using, Sublime, is a versatile editor that has automatic syntax highlighting, and when I saved it at .java, then it was able to figure out that this guy is writing a Java program. So let me find out those keywords and color the keywords appropriately. So wherever you have public is in pink, static is in pink, right? So class name and method name is in green. All right, good. So done, right? The program is saved. Now let me tell you a few things. If you want to see what do I have here, I can check dir. Dir is the command in DOS which lets us see the contents in the folder. So I am right here in C directory, CSE114 subdirectory. That you can confirm here, C CSE114 subdirectory. When I say dir, enter, then it will tell me that I have welcome.java. That's something I created. And please have a careful look. I don't have anything else in this directory. CLS, let me try one more time. Okay, ignore all these things, just pay attention to what I have in this directory, which is a folder. Directory means a folder. So my folder is CSE114 in C directory, and the only thing that I have is one file with the name welcome.java. That's right here, I just created. Now just one file with the name welcome.java. Now let me compile. So how should I compile, right? So the name of the compiler for Java is Java C. And how do I compile? I'll say Java C and the name of the source file, which is welcome.java. Okay, so for compilation we will call the compiler in Java, which is Java C, and then after Java C we'll have the name of the source file. So when I say Java C welcome.java, let's see. When you don't see any other message, that means it's a good news, and which means that you did not have any error in your program and compiler was happy with our program, and we should expect something. Let's see, what do we have, right? Welcome.java is something I have written right here, but my compilation process was successful, and that resulted in creation of another file called welcome.class. Now what is this welcome.class, which I did not write? So this welcome.class is the bytecode program that Java created after the successful compilation. Alright, so when my compilation was successful, how did I compile? Using Java C and the name of the source file. It was successful, I did not get an error. Then that resulted in the generation of the bytecode, and the bytecode has the extension .class, and its name would be the same as the name of the source file. Alright, so this is something I love to share with my students, and let me do that one more time. Let's see, what do we have in this .class file that we did not write, and try to understand if it will make any sense to us as a human being. Welcome.java is right here. We wrote that, so we kind of understand what did we write. So when I open welcome.class, then let's see, what do we have. These are what? These are some numbers. 00390614 and then 6A65. Don't worry about these letters F, A and all that. I will explain these things. This is hexadecimal representation. We'll learn about that. But what you have here is in fact in binary, right? So this is bytecode. This is something which will make more sense to the Java virtual machine, not to us. All right, yeah. And this is a bytecode file which we got after the successful compilation. So we are not done yet. We are just done with one stage, which was compilation. Now when we have to run this program, we will call the Java virtual machine. And how to invoke Java virtual machine? By calling Java, not Java C. Java C is for compilation. So I'll say Java welcome. Alright, not welcome.class, not welcome.java. We should have welcome.java when we are compiling. So I will say Java C welcome.java. But I should not say Java welcome.java. Why? Because I want to run the bytecode. And what is the bytecode? Bytecode is welcome.class. But the interesting thing is that you should not say Java welcome.class. Let me do that. Why? Because when you invoke the JVM Java, then it by default adds .class as it will by default add that .class extension. So when you say Java welcome.class, you'll get an error. Okay, so how to avoid this error? Let's not add a .class here. Anyway, we know that this is a .class file, but by default Java JVM will add it, right? So we will not do that, and let's run that. Okay, one more time. How do we run the JVM? By using the command Java and the name of the bytecode, which is welcome. Let's run that. Okay, we are done, right? So the program worked. Alright, so please do these exercises. These are not difficult. The only thing that you might face initially is the setting up of JDK, which I believe we can help you. the TAs are there, they will help you in your very first lab, so please don't miss that. I will be posting the announcement about your lab and the TAs to reach out to. Okay, now let's go back to the lecture slide. Alright, so now we are familiar with this code because I wrote something like this in the demo. So you can use Notepad or you can use any other editor. I used Sublime. Alright, so this is our source code. Now this whole program and the whole picture that you have is giving us an idea about the program. When you're writing a Java program, then what will you do? So first you will create a source code. You create it right here. You will save that. I saved that. You remember when I finished typing everything, I saved this file in my C drive CSE114 folder, and I saved that as .java. So I saved that program as welcome.java. Right? Good. After that, I did the compilation. In compilation, I did not have any error. So if you have an error, then you should go back and you should edit your program till there is no compiler error. You keep on changing your program till you get no compiler error. It is very common to get the compiler error. When you are learning to program, definitely you'll have a lot of compiler errors, and even if you are a very smart programmer, you might sometimes have compiler error. Excuse me. Now when you compile the source code, how did we compile? We'll say javac welcome.java. Name of the compiler is javac. Okay, so if you were successful, you will get a bytecode. This bytecode is a little strange from what we saw, but it doesn't matter. Bytecode is something which will not make much sense to the human being, so we should not worry about that. If we successfully got the bytecode, then we will run the bytecode by calling the Java virtual machine. We'll say Java and welcome, and this should be able to run our program. Okay, if you have an error, go back and try to fix your program. If not, then you're done, you're good. Alright, now let's try to understand, like, why did we write our program in this way. So this is slightly different from the programming language like Python. Let's pick the Python because that I believe is one of the easiest language compared to Java. So if you have to do the same thing like print hello world, which is different from what I was doing in the demo, I said hello CSE114. So when you have to just print this message hello world, then in Python it is so easy. You don't need to create any class, no method needed. Just write one statement and you're done. You say print hello world, you're done. But in Java, you need to first create a class, and you might call that class as welcome or hello. In this program, we are creating a different class. We are calling it hello. So you should say public class hello, and in that class you will create one more method, which is the main method, and in the main method you will have this fixed syntax which we use to define the header. This is called the header. Okay, from this line starting from here till this is called the header. So the header of the main method will remain the same in most of the programs. When we are writing main method, its body will be different as per the need. So this statement that you had in Python, you can put that here, but it's not as simple as print hello world. You need to specify this print method. In place of print, we are using println. We'll discuss like what println does later, but let's try to understand what it is doing here. So println is a method which we are using to print this message, which is hello world. The message should be in double quotation. Why? We'll learn that. Now system.out is something we need to specify. Why? Because we are telling the Java that there is a class named system in Java. I want to use a method println println which exists in the Java class, right? So in the system class in Java, so I should tell everything. I should tell the Java that please use println method which is defined in systems.out. And what is system? System is a class that exists in the Java. Alright, so when you run that, you will be successful and the result will be the same as you will get in running the same program in Python. Alright, so let's try to understand like why did we write this program this way. Okay, so one thing you will notice is that we are changing the name of the class everywhere. It's not done by purpose. Probably I should have kept the same name to avoid the confusion, but you can learn from these cases also, like the program is correct in all these three places. We are calling this class as welcome in some place, we are calling it hello, we are calling it my program. That's the same thing, right? Doesn't matter. The only thing that should change is your source file should have different name. You should save your file as excuse me, welcome.java, hello.java, and myprogram.java respectively. Okay, so now we will try to understand line by line, like why did we write it this way. So let's look at the outer block, right? So what is this block doing? This block is defining your class. So every Java program consists of one or more classes, right? A class is a block of Java code, and classes are indicated by the keyword class, right? So this is important. Even public is important, but if you miss public, you are still fine. But make it a habit, right? Let's learn it, because you have to learn a lot. Why not start learning about writing this very simple program? So classes are indicated by the reserved word class. Now public is a modifier, is a keyword which belongs to the modifier category that tells Java that the class can be seen or used all over. So in Java we have this control. When we are writing a program, then we can control like who can access this program. So this is a very strong feature. You can protect your program from being accessed by other people, right? So when you say that this class is public, that means you are very lenient. You're very lenient, generous. You don't want to impose any restriction on the class that you are creating. So you'll say public. So the class, my program, is public. I don't want to impose any restriction on this. Anyone who wants to access my program can access my program or class. Now the curly braces surrounds the contents of the class. These two. And class is a block of Java code, right? This is a block of Java code that is defined with the keyword class. Alright, so now let's move on. We understood the outer block. What do we have inside? So we have a method. A method is a block of Java. This is the method. And here you'll have statements. We have just one statement. Block of Java statements. Main is a special method. It tells the JVM how to start the program. So when you said Java my program, so first you'll say Java C my program.java, which will result in the creation of my program.class. Then you will use the JVM and you will execute. Okay, let me write this thing, right? That will make more sense, I believe. And yeah, so when you have written this program, right, so it will be written in the file called, you will have the file name my program.java. So you will compile it. You will say Java C my program, there's no space in between. Okay, let me make P like this. My program, that means we don't have any space. You'll hit an enter, and I don't see any compiler error. So what will happen, it will result in creating a file called myprogram.class. What is it? This is the bytecode. Okay, so that was compilation. Later on, what you will be doing, you will say Java, that means you are invoking the Java virtual machine, my program, enter. Alright, and which will result in the hello world. Now when you set Java my program, then you invoked Java virtual machine. Now when you are invoking Java virtual machine by issuing this command like Java and my program, which is your bytecode, now JVM will look for the main method in your program and will start running your program from the main method. So right here when you said Java my program, this is where JVM will start looking for the main method. That's what we mean, right? So main is a special method. It tells the JVM how to start the program. So if you don't have a main method in your program, you might get an error, right? That main method was missing. Okay, so every Java program, not every class must have a main method. Okay, so for the simple examples that we'll be doing initially, maybe for a week at least, we will have just one class. When we learn about object-oriented programming, then you'll be working with more than one class. So if you have multiple classes in your program, even then you are required to have at least one main method. You can have more than one main method, one in each class, but you should at least have at least one main method. Every Java program, not every class must have a main method. So in your program you should have at least one main method in at least one class. The body of the method is surrounded by curly braces, which is similar to the way we define a class. Now let's try to understand the statement which we have in our program, which is system.out.println, and then in the parenthesis you have the message that you want to print, and the message should go in the quotation marks, right? So these are important. Alright, so these are important. Whatever you have, the message should go in the double quotation. Why we do it? Because this is a string, right? What is a string? Let's wait for that. It's a data type. String is a data type which stores the values like name, address, which is a sequence of characters, right? Name, address, or any paragraph. So that will be a string data type. So what is system.out.println? Let's try to understand. Is a Java method which we did not write, right? So I did not write any method with the name println. I have only written main method. So this print.ln method that you're looking at is something which Java has written, and we want to use that method. So system.out.println is another Java method. It tells the program to print something to the console or the screen. Console means the screen. The information to print goes inside the parentheses. Now this is what you can try, okay? So the best way to learn programming is to practice. So just type it the same way and follow the instructions that I provided. And this you can change here, right? In place of hello world, just write anything. Hello Sam, hello Peter. So these things you can change. In place of one statement, write multiple statements and see what is happening. So the information to print has to go inside the parentheses. It should go inside these two. Alright, here we are printing a string of characters. This is called string. This method calls me. This is a method call. Main was method definition. So this, well, let me try. Okay, these are few things I try, but it will make more sense when we learn about methods. So there are two methods. Okay, this is one method, main method, which we defined. What do we mean by we define? That means we have written its body. We know what is there in the main method. We know that there is one statement in the main method, and we have written our own main method. Whereas if you look at this println, then println is also a method, right? But this method is something we did not write, right? Did I define println anywhere? No. So println method we are not defining, but we are calling it. We are calling, right? We are saying that we are calling this method from the method which exists in the Java API. So there is a difference. Defining and calling. We have two methods. Main method we define because we have written its body. We know what are the statements in there. Whereas println we did not define. We are just using it. Alright? Yeah. So there is a difference between method definition and method call. Alright, so we know how to compile the Java program, but anyway, let's go over that because it will be a good exercise. Write and save your source code into using a text editor. We use Sublime. The source code must be plain text file, right? So please don't write your source code on um, in Word or any other word processor. Better you write that in a very simple text file. Okay, and the file should be named after the class it contains. Alright, so I call that as welcome.java because the name of the class was welcome. So if you're calling that as my program, then it should be saved as myprogram.java. Run the Java compiler javac. Alright, to compile your source code. So if you're calling your class as foo, then you should save the file as foo.java. And in order to compile that, you should use javac foo.java. This will produce the bytecode with the name foo.class. Then when you have to run this program, you need to call the JVM. And how do we invoke JVM? You should say java and foo, and your program would run. Note that .class extension is omitted, right? So this is something I was explaining to you. The JVM fills that in automatically, so you don't need to provide .class. We did not. Just say Java and name of the class file without extension. JVM will put that extension by itself. You can only directly execute a class file that contains a main method. Okay, so main method is must to execute that class. So if you want to see like how did this program run, so let me give you some animation. So you wrote this program, and when you are doing this thing, right, when you're saying java foo, then the first place where the JVM will go would be the main method, and from the main method you will run the first statement, and after that you get the output. Alright, so in the Java program we can write a lot of things. We have comments. The comments are there for the programmer or for other human being to understand the logic behind the program. Comments are ignored by compiler, right? So reserved words, we have seen these reserved words are the keywords like class, public, static, void, main. These are all reserved words. We will see a lot of reserved words. We should understand what these reserved words are for, and we should avoid using that for our own variables that we will be creating in future. When we are using these reserved words, then we should be mindful of the fact that this will have an impact. When you say class, then Java will understand that you are about to create a class. Similarly, when you say public, then that means that you are saying that your class should be accessible to everyone. Okay, so some of the reserved words are used as modifiers. Like public is a reserved word which is an access modifier. Now, what are statements? We did write one statement, which I'll say will be the most basic unit of the program. The program will have a number of statements in it. The simple program that we wrote had just one statement. So don't worry about these things. These we'll discuss about these in detail as and when our program gets a little more complex. Blocks, we did look at the blocks. We created two blocks. Blocks are denoted by opening and closing curly braces. We wrote a block for class, and then inside the class block we created a method block. Classes, we will create classes, we'll write methods. Then this one main method. Now we did learn about comments, right? So there are a number of ways in which you can comment. So I use this line comment. So whenever you have a double slash and after that you write anything, then the whole line is commented out. So these double quotations will be used to comment a line only. If you want to comment a paragraph or something that goes beyond one line, then this will not work out. For that you will have to put the whole comment in between these two forward slash and a star in between. Alright, so when you have to comment a paragraph multi-line, then use this style, the paragraph comment. Okay, then Java doc comments, that is something you should ignore. Now let's look at some reserved words. What are reserved words? Reserved words or keywords are words that have specific meaning to the compiler, right? They have a specific meaning to the compiler, and we cannot use these reserved words for our own purpose, right? Because that will not have. Okay, so class is a reserved word. So when you're using class, then it means that Java, the compiler will interpret it as that you are about to declare a class. So you can see there are a lot of keywords, right? Abstract, assert, boolean, break, and we'll learn about all these things very soon. But if you can get an idea about that, the fact that we have a lot of keywords in Java. Modifiers, so some modifiers are used in Java, and these are some reserved words, and they will specify that how can we use the data object or the methods or classes. So modifiers can be applied to class, to methods, or the data, right? And that will control how they can be used. Excuse me. So we have different modifiers. Modifiers could be public, static, private, final, abstract, protected. We'll learn about these things. So when you say that something is public, when you say that this, wait a second, I should go back to the pointer. Now, when you say that something is public, data is public or method or class is public, then it means that it can be accessed by other programs. We are not restricting the access to it. Whereas if you call something as private, if you have a data or a method which you're calling as private, then it cannot be accessed by other programs, right? You are very conservative about this. We will use public and private. Now, what is a statement? Now, a statement represents an action or a sequence of actions, right? So this is more is a better definition compared to what I was giving. So a statement represents an action or a sequence of actions. So when you say a system.out.println and welcome to Java, then that will result in, that's an action which will result in printing this message on the console. The message is welcome to Java. And every statement is terminated by a semicolon. So this is important. Block, we learned about blocks. A pair of braces in a program form a block. Right here we have two blocks. Outer is a class block, inside is a method block. And we'll be using a lot of blocks in the program. There are two styles of block. It is up to us how do we want to do. I prefer this style where the block starts towards the end of the line style, you know. So that's how I followed. If you remember how I created that. So once that class definition starts here, I'll say public class test, and after that itself I will start this block by putting an opening curly brace, and then I'll write the method name, the main method with its header, and in the same line I will start the block, the next block, which is for the method. It is called end of the line style, and there's this next line style also. In the next line style, you take this opening curly brace to the next line. That's the difference between these two. End of the line, next line. Alright, it is up to you whichever style you follow. This is fine, right? But what is required is that if you are following the end of the line style, then please keep that style throughout your program, right? You should not mix these styles because mixing the style doesn't look good. Now when you write a program, then you can have a number of errors possible. So there are three kinds of errors that you may get in your program. So the syntax error is something where you are messing up with the syntax of the program. So we will learn about the syntax. So I can introduce some syntax error in my program deliberately, and I can tell you why is that happening. So if you miss out a semicolon, which we need to terminate a statement, then the compiler will issue a syntax error. Syntax error because every statement that you're writing in the Java program needs to be terminated by semicolon. So compiler is smart enough, it will identify that there is this error, this guy forgot to put a semicolon, and will raise a compiler. Then there are some runtime errors, which are the errors that compiler won't be able to figure out. But while running the program, compiler will find out that it's not possible to run this program. So what could be the situation? Like dividing by 0. You cannot divide by 0. Divide by 0 is not defined. So this divide by 0 will not come when you compile the program. But when you run it, that's where this runtime error will occur. Similarly, there are some logical errors which are not compiler errors and are not even the runtime errors. The result of the logical error would be something. You'll get an output, and that output will not be a correct output. Okay, so let's see if I have some examples. Okay, good. So I have some examples. Here we have a syntax error. It is a syntax error because you have a variable I is equal to 30, but you are not declaring its type. So you should have done int I. Okay, so let me correct that as well. Right, so I'll use the pen blue. So I have an error right here. I should say int I. Now this will fix. And if you don't have int there, then anyway compiler will say that you are missing the data type, and it will help you. Compiler helps a lot in fixing syntax error. You'll understand what I mean as and when you start program. Now this is runtime error because you cannot do division by 0, right? So it's undefined operation. So there are logical errors. So well, this is a little interesting because you need to understand the programming structure, the syntax, to identify what is the logical error. But anyway, I will try. Excuse me. So what this program is doing actually, we'll learn about scanner later, maybe in the next video lecture. We are asking the user to give some input. So when this program runs, it will prompt the user to input a value, and the user is supposed to input a value between 1 and 100. All right, so um, what we have to do is we need to add those numbers, it seems, uh, inclusively. Okay, so you are saying display the number is between. Okay, so this condition, when you are saying inclusively, then that means this should be true even if you have the input as 1 and 100. So this operator that you're using is incorrect, right? So it should be less than or equal to, less than or equal to, right? So that was the logical error. So what will happen, there's no syntax error. Compiler will be happy when you run it, when you compile it, and even when you run it, there won't be any problem. The only problem will arise when your input is 1, it will say that number is false. Why? Because you did not have equality here. So since this is inclusive, you should have an equality here and equality here also. So this is a logical error. So don't worry if you don't understand these things at all, because this is little involved. We should know how the scanner works, we should know what is this thing, and we should know about these operators, these things and all, which I did not teach. It will take at least one or two more lectures to get to that point. Alright, so that was it. I'll stop right here and I'll see you in the next video lecture. Bye bye, take care, and please practice. Thank you so much. Bye bye.